Hi, I'm Max Hollander.
Hi, I'm Adam Yeso.
This is our synthesis project on Punnet squares.
So before we teach you about Punnet squares, you're going to need to know some vocabulary. Homozygous means having two identical alleles of a particular gene or genes. Heterozygous, it means having two different alleles of a particular gene or genes. Now, an allele is one of two or more alternate forms of a gene, and they are found at the same place on a chromosome. A genotype is the arrangement of alleles, and the phenotype is the trait that is shown in the organism. Dominant, the allele that is shown in a heterozygous or a homozygous dominant organism. Recessive, only is shown when an organism is homozygous recessive. This is how you fill out a monohybrid cross. The top and the left side represent each one parent. This capital H is dominant because it is capitalized, and the lowercase h is recessive because it's lowercase. This is a heterozygous because it has one dominant and one recessive, and parent 2 is homozygous dominant because it has two dominant. To fill this out, all you have to do is see what the top and the left side is, and since they are both H, I know that is a homozygous dominant offspring. The same thing for right here. Now, for the second pair of offspring, I know that this is a recessive allele and this is a dominant allele. So it would be a heterozygous, but still showing the dominant trait for both of them as well. And this, since I have two heterozygous and two dominant, this means that my ratio would be 1 to 1. Before we move on, you should know that this is the genotype ratio. So this is the different codes. And it's because these all show dominant traits, the phenotype ratio would be 4 to 0 or just 0 or 1 to 0. And so for the next trait, or for the next square, you have a homozygous recessive for the first parent and a heterozygous one for the second one. And for this, you fill it out the same way and you just get different pairings, and I believe it's the same ratio, but or at least for the genotypes, it's the same ratio. It's still a 1 to 1 ratio because you have your two heterozygous and your two homozygous recessive. But now, since these are homozygous recessive, they show their own trait other than the dominant trait. So this is the phenotype and this is the genotype.
This is how to do dihybrid crosses. So a dihybrid cross is like a monohybrid cross, but basically it deals with two traits instead of one. So how to figure out the 4 different combinations for each side, each parent. So it's called the FOIL method. You get the first, and the first letter, like for this, is a big T. Then you get the opposite, which is the big H, so TH. Then you get the first one again, and then the other side, so big T, little h. Then you get the small t, the big H, right here, and the small t, the little h, right here. And you just repeat that process for this, and then, like we're gonna draw this out, right here, big T, little h, or big T, little t, so we got big T, little t, 2 big H's. So, we got, obviously I filled in the chart because that would take a long time on camera, but we got, like, for example, just big T, big H, did that for all of them. And the little symbols in the corners were to make sure that my phenotype and genotype ratios were correct. Obviously you want 16 in total because there's 16 squares. Big T stood for tall, small t stood for short, big H stood for hairy, small h stood for not hairy. And then for the ratios, we got there was 2 different big T, big H, 4 different big T, big H, little h, continued on. It ended up being a 2-4-2-2-4-2 ratio. And then we got the phenotype, which is the actual traits that were exhibited like through these genes. You got 6 that would be tall and hairy, 2 that would be tall and not hairy, 6 that would be not tall but they would be hairy, and 2 that would be not tall and not hairy. And yeah, the dihybrid cross is similar to the monohybrid cross, and it just ends up showing what the potential outlook of the children or the offspring of 2 parents could be.
Thank you for watching. This has been
Punnet Squares!